Well, hello everyone, and thanks for joining today's webinar. This is Fred Schenkelberg, and part of the Ascendo Reliability webinar series, and very much welcome you to joining today. And it's one of my favorite topics today, so I'm hoping you get a lot of your insights and impressions of your interactions with vendors, or if you are a vendor, what kind of data and information are you being requested to provide, and what are you providing? So, Myron, you lost Otto. I turned it off just for a second. Is my audio coming through at this point? Is everybody hearing me all right? Okay, Neil, you got me. Myron, you still got me? All right, good. Yeah, usually I have a little control for the sound, the music, and I can dial it down slowly and then bring on the recording. But for whatever reason, I don't have that control at the way I'm using it right now. So whatever. So hopefully everybody can hear me. I'm going to leave this screen up just for a few seconds. Over to the right of the rotating slides, there's a pod called Download the Slides in the paper here. There's you just highlight like vendor data slides or the reliability case standard, and I think you can highlight them both at the same time, and then click the download files, which will become available um, if you want to. And I'll bring that back up as we wrap up the session too. But welcome. We're going to talk about vendor data. And some vendors, as you know, do a wonderful job providing you reliability information and do a lot of work to make sure that they provide good information. And unfortunately, in a few cases, it's pretty poor. It's pretty bad data or unsupported claims and those kinds of things. Now, I'm going to preface all of this discussion with that of all of the vendors and all of the companies I've worked with, is most people are trying to make a reliable component or a reliable system or device and to provide a solution that actually works for their customers. So I don't think anybody's actually trying to deceive anybody by not doing good reliability work. Some of it is ignorant, some of it is they just don't know how, which I guess is ignorance. Some of it is they're being asked for the wrong kind of information. And many of you I recognize as being had listened to some of these before and follow me on different social media and blog posts and so on, know that if a vendor is only asked for MTBF and they provide MTBF and the customer goes away and doesn't ask for reliability information in another way, they think they're doing their job. And so part of what I want to talk about today is, well, how do we get reliability data from our vendors such that we have a much better chance of getting useful reliability data? And so that's what today's talk and discussion is about. So I'm looking forward to your insights on that and your background. So just as I should probably have created a poll. I didn't think of it until just now, but I was wondering if there's people on the line that are vendors, that if you are providing components or subsystems, that's your business. If you are, go ahead and jump in the chat window. And what's the most common question you get regarding reliability? How do people ask for reliability data? Man, you're still not getting me, huh? I'm getting a bunch of people that are getting it. Um, so let me make sure so Kirk can hear me. All right, thanks, Kirk. Um, let's see. Let me ask Myron to try logging out and back in. Sorry about that. Hopefully it'll work for you. Understanding that you probably can't hear me talking, so hopefully that happens. But are there any folks out here that so you're not getting sound with Internet Explorer? Well, that's odd. Oh, I wonder what's going on with that. So hopefully enough people are getting it. All right. So hopefully Myron can log back in on a different platform. I you would imagine that Adobe Connect would work with Internet Explorer, but I guess various things don't always work. That's unfortunate. Um, so yeah, understand, Greg. Uh, so anyway, it doesn't look like I got any vendors out there that let's see, Chris is doing complex systems require MTBF and uptime. I'm sorry to hear that. That's usually not a good practice, but we'll probably get into that. And I think next month or the month after, I'm talking about MTBF and my adversity to that and just how bad that is. But yeah, that's unfortunate. All right, thanks, Myron. Glad you're back in and going. All right, so let me relate just a little bit of my experience on this, and feel free to chime in um, on the chat window if this sounds familiar or if you've seen something like this. Oh, and before I forget, one advertisement here is I've just recently launched a new website called Ascendo Reliability, and many of you may have come through that site to register for this event. But one of the things I'm most excited about is the reliability.fm. It's a podcast network focused on reliability engineering. And the recordings for the webinars, the previous year, almost 2 years worth of webinars, are now available through iTunes and on the site Ascendo Reliability. Plus, I just recorded the 17th episode of Speaking of Reliability and working on the editing and getting those uploaded, but those will be out very soon. And we'll also have the recordings from Dare to Know, the interviews with reliability thought leaders that Tim Rogers does. And we'll be pushing those up to iTunes here, hopefully this week. But look forward to the addition of podcasts to this hub of professional development material. Um, right now, it's all free. We expect to be adding courses, and if you're interested in a particular course or topic, if you'd like to go into more depth on a particular area of reliability engineering, please let me know. And I'll work with my team, folks that I'm working with, other consultants and other reliability professionals to craft and bring these courses to life. And so I'm looking forward to building out this professional development site. So if you haven't seen it yet, please check it out. So reliability, it's what we do, right? A lot of us are professional development or professionals at what we do. And it doesn't, I had a question the other day whether somebody needed a certification to be a professional reliability engineer. And I don't think so. My response was a certification is nice. It provides a milestone to, to let others know that you take your profession seriously, and it gives you a good exercise in broadening your knowledge in many cases. But is it an indicator that you are a professional? And I don't think that's true. I think it's more about how we operate, how we work, following an engineering code of ethics of being forthcoming and honest and doing good work and understanding our limitations and so on. I think that's more important. Now, I bring this up because uh, we work with a lot of different people, and in our product development process or in our factories, we often look at data sheets. And oftentimes on those data sheets, there's a claim of reliability or life or dependability or duration or availability or something to that extent. And I'm sure everybody on the line today is seeing data sheets with reliability information on it in one form or the other. Yeah. And Andrew, CRE is great. It gives us a milestone, really. And I know a lot of people that pursue or have a CRE, yet I think it's more our individual actions that make us a professional. And we don't have a professional engineering license for reliability. There's electrical engineering and mechanical engineering. I know that chartered engineers is similar in some countries, yet I don't know that there are um, state licensing for reliability engineers. But independent of that, I think it's more about how we work. Now, part of that is that it overlaps with what's on these data sheets. It's how people present reliability information. So, um, some years ago, quite a few years ago now, actually, a colleague and I were looking at a uh, and I think you all have heard this before, if you've listened to any of my presentations before, is that in reliability, especially for electronics, there's usually three suspects for what limits the reliability of a device. And fans is one of those. It's maybe not the top one, but it often is a weak link in a product. And my colleague and I were looking at, well, which fans were the best and which ones were the worst of all the arrays of different fans that we were using for these electronics boxes. And we were looking at uh, spare parts sourcing. We had a series of warehouses that worked with customer support, and as fans got replaced or used in the repair centers, we had a running tally of which fans were used most often and so on. So we normalized it against so we normalized it against the volumes of units shipped and so on, and came up with a rough gauge of which fans work better than others in our particular applications. And one company just stood out as just heads and shoulders more reliable. Their fans just didn't fail, uh, an order of magnitude better than any other vendor's fans. And so I was asked to go sort out, what do they do different that makes it better? So on their data sheets, that was the first place I looked, as I pulled up the data sheets for their fans, and every single family of fans, they had a bold box with 50,000 hour life. And that was the sum total of their reliability claim. And well, I'm not really sure what that meant. So I went up on the website and I didn't find anything there. I didn't see anything. So I called them. I called the group and I got a director of engineering and asked this question: what does that mean? And he says, well, that's the reliability value. That means that it's a 50,000 hour MTBF. You could use that. And I'm like, okay. And then, well, what do you do to support that? What's behind this value? And I said, fans aren't really a constant failure rate. So do you have Weibull information or bearing wear out failure rates or something like that? And he was like, well, no, not really. Let me put you through to somebody else that may help answer this question. Now this was the director of engineering for this company. And he put me through to the CEO and who had founded the company and started it. And it wasn't a very big company, so that wasn't. I guess I was surprised at this person answering the phone directly like that. But be that as it may, and he said, "Well, why don't you come on down to the company and see what we do, and I'll show you how we design and test our products and why we can claim this." He said, sure. So a couple weeks later, I'm down in this guy's office. He shows me all of these data sheets with this 50,000 hour life on it. And so once again, I asked him, why, what's behind this? What do you support this value here? And he says, well, we get really good engineers, and we have a inherently strong design, and we try to make it as robust as we can, and we charge a little bit more because of that, but that's what we do. And this number here, well, that's pretty much the same as all the other companies that put out data sheets for fans, is they put 50,000 hours. And so we thought we'd put that on ours too. What? No, no, this number is just kind of fiction. And I'm like, okay. So he said, well, let me show you our testing. This might help to prove that this claim is okay. And so he took me around the corner, and there was a window along the hallway that showed a set of benches that had all of these fans spinning, and there were little streamers on them, so that all these things were flapping in the breeze. So the fans were being used with no back pressure in a controlled environment temperature. It was very clean in there. It was in not a lot of dust or debris or carpet fiber or anything else coming into these fans. And they weren't actually cooling anything, so, and the air was air conditioned, so it was relatively safe. And I noticed that there was a big box in the corner that was, I thought, a power supply feeding all these fans. And he goes, no, 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 that's a backup power supply, an uninterrupted power source. And because when we have a power failure in the building, um, it takes us about a bunch of time to get all the fans spinning again. We have to go in there and get them a little kick to get started. And so we stopped we walked in the room, and I turned off a couple of fans, and I looked at them, and you could tell just by feeling them that the bearings were basically gone. They were very, very sloppy in the axle. I was like, and this is your justification? And so I spent the day with this team trying to understand what they did that made really, really good fans. And I didn't want to dissuade them from doing what they were doing well. Yet it was a disconnect from what they were reporting and how they understood it. Now, that may well be an exceptional case. I'm just not at all sure what these guys were thinking or what they were doing. Yet I have seen other vendors and other data sheets that did remain unsupported, or they would do very cursory work to justify their claims, or they would make very vague claims on their data sheets. It's a matter of when you start asking better questions that you can see those disconnects. And that's not really our purpose. That's not what we're trying to do. What we want is we want components. We want to buy materials and components and subsystems that integrate into our products and our services that we provide our customers that will work in our environment and under our use conditions and loads and so on. And so electrical engineers, mechanical engineers, procurement engineers, a lot of people look to the data sheet as the starting point. But in general, we ask the vendors a lot of questions, especially for custom or semi-custom parts. But what we're really looking for is some evidence that this component, whether it's a fan or a capacitor or whatever, will actually work in our environment. Now, the data sheet also includes things like operating conditions and temperatures and different maybe derating information or temperature limits or operating limits, things like that. Yet that's not really answering the question of what we need to know is, well, how many will last for 10 years at 60 degrees C? Just knowing that it's 50,000 hour life doesn't really answer that question. So what we're looking for is information we can use, one, to make decisions, and two, to incorporate into our system model to get an idea of how good our product is going to be. And it's a common technique is to look to vendors because we hope, and I've had that dashed a few times, but we hope that vendors have understood how their product works and have done the testing that's close enough to our application that we can answer that question. Well, what's the reliability at 50 hours or 50 days or 20 years? how will your product work within my system, my application? Now, we also use it to balance the purchase price and all these other factors that we use when we select components is, and cost is often a very big number. But if I can balance cost versus reliability, I, I can balance the cost per failure. If I have a series system, for example, and I know that it costs me $500 if that box fails, but if your power supply is causing that failure, it may be worth adding an extra 50 cents or a dollar to that component to get a more durable or more reliable product. But I need good failure information in order to make that decision. And also, hopefully, I get very consistent information across the different vendors so I can actually do comparisons. For example, if I'm looking at fans and one of them is just taking 100 fans and running them each for 2,000 hours, uh, they can claim, I think it's, if I do the math quick in my head, 200,000 hour MTBF, if they're making the assumption that it has a constant failure rate. I may have missed a decimal point in there. But anyway, but that's compared to somebody else that's doing testing to failure in a use application and gives me a Weibull distribution. And their characteristic life is, say, 200,000 hours. Now I'm comparing apples and oranges there, but I need to know what's the underlying test methodology, assumptions, what distribution you're using, all those kinds of things in order to make that comparison. So when I have that information, I can add the cost per failure and I can start balancing, well, what's the right trade-off for price versus reliability? And I'm sure you're familiar with other examples that where that becomes really important. And also, I think it's a subject of a whole nother webinar, probably more like a rant, where I talk about those procurement engineers that continue to reduce cost despite the increase in failure rate. But that's a subject for another day. So, Myron, I just saw your question, and yeah, this was the best company, and we reviewed, I think, 30 different fan vendors. These were cooling fans for, say, small computers or servers, and yeah, it was tough. And yeah, I agree, Sandra. It's tough getting good information from vendors. And some of them are overwhelmed, right? They've got 100 different clients or customers asking for different kinds of information. So they put up a suite of standards or a suite of basic information and say that's what we have. Others actually do a really good job of understanding their product. Yet the sales engineers and the teams that are working with customers are asked over and over again for MTBF. So they think that's all they need to provide, even though there's good information in the engineering teams. So it's what I'm really after is how do we get the information we actually need? So what can we do, right? Well, if we're working with a vendor and we suspect that their data sheet information is fiction, or when we first ask for questions, they don't, we get the list of 10 standards. Well, we ran it at 85 degrees C at 85 RH for 1,000 hours. Therefore, it must be good. And in responses like that, well, we can guess. We can use our own engineering judgment. If we have our own field data or whatever, we can fill in the blanks. Or we can accept their information and try to guess at how they did the testing, how to translate that into a failure mechanism and time to failure. But that's a little more than a educated guess. Now, we can use what they give us. We can put in 50,000 hours as an MTBF value with an exponential distribution, but that may likely be an unfair representation of the reliability. It may be over or under significantly. I think it is a subject for a different pod or a webinar I've done where, um, oh, I'm drawing a blank on his last name. Jeff. He's a professor in England, been also involved with the IEC dependability standards, and he wrote a paper some years ago that looked at all of the different parts count prediction methodologies and compared them to a really good set of data from a set of boards that were in the field, and they had really good time to failure data on these systems, and found that prediction methods, the Mill Handbook 217 and similar structures like that, were off by 100% negative or plus 600%, and all over the map. And they just a little bit less than just a guess, in off by orders of magnitude easily. So if a vendor has given us just, well, this is the Mill Handbook 217 prediction for our component or subsystem, it's an indication that they really don't know how reliable their part is. And that number is just, in my opinion, just fiction. But I think what we're after and what the title of this talk is about is, well, let's just ask better questions. Let's ask the vendors the right questions so that they're more likely to give us good information. So let's explore that a little bit. Now, what we're after, and one of the first questions I ask any vendor is saying, hey, look, you know your component. You and your design team have selected materials and manufacturing processes. You have seen failures, both in your development process and in your manufacturing process and from customer returns. So what fails? Is it a polymer degradation? Is it a PN junction decaying or degrading? Is it shorts? Is it primarily manufacturing defects that escape your system? Is it a vibration and flex that cracks your system? If we don't treat it correctly, is that what causes the predominant failures? So I'm almost asking it as if I'm doing an FMEA, a failure modes and effects analysis. Ask the vendor what will fail, and don't accept that it never fails. I don't know of any product ever that has the ability to never fail. Now, if it fails after 30 years and I only need it for 5 years, well, how do you know that? Have you been in business with this technology and manufacturing process for 30 years? Or what's the supporting information to knowing what will fail? Now, as you know, working with your own design teams and engineers, if you ask engineers this question, what will fail, you'll get a range of different answers. We'll get deformation and corrosion and delamination, or on and on and on. Well, which one's important? Which one's salient? So this question often leads to a discussion about, well, how are you going to use the product? Or what's my operating conditions? What's my, is it within the range of where you expect the product to be used? Or am I pushing one of the boundaries? And if I put it at a higher vibration environment, will that change what fails? So probe with your vendors their knowledge of how it fails, which is completely different than asking for reliability. But once we know the failure mechanisms, then we've got a foundation then to create the reliability information we really need. Or ask them the second question, which is, well, when will that failure mechanism occur? So if I know that it's cracking, say a ceramic capacitor cracks when you have too much vibration, right? Then when would that occur? How would I know that? How would it manifest itself? How long before I get this defect will it show up in the field? Those kinds of things. So it's once I know the failure mechanism, what will fail, then it's asking, well, how does your experience or field data or test information translate that failure mechanism into time to failure data? So it's, how does that work? How do you connect those two things? And if you've done any accelerated testing, you know that you need to know the failure mechanism. What's causing the failure to manifest itself? And then we can usually figure out a way to determine the time to failure. Yeah. So I see your comment there, quality A qualified program is the gate activity. You know, in an ideal world, that's true. And for a vast majority of our components, that just doesn't happen. Reminds me of work or talking to Craig Hillman some years ago while he was still with University of Maryland at Kels, and he was running a failure analysis lab. And he put up some information one time in a presentation that kind of summarized all of the failure analysis their lab was doing for their clients. And a third of the failures of products in the field, the electronic products, was due to capacitors. Now, think about that for a second. Look back at your own organization. If you're using electronics of any sort, how many people are actually paying attention to and designing and working with your suppliers to get reliable capacitors? Probably not many, if any. Now, you probably have an FPVGA or a custom ASIC, and you got a whole team of people working on that. You may have an electrical engineer working on power supplies and or the motherboard or the control circuitry, things like that, the logic elements. But capacitors in and of themselves are often just a discrete component that's just thrown into the product to provide that functionality. Um, so, hey, you know, let's take a look at even when we're dealing with capacitors or we're dealing with something that's considered a commodity, take a look at your own data is what's causing failures in the field and what's the failure mechanisms. Work with your vendors and ask them these two questions. What will fail and when will it fail? Right. So Myron, I'm not sure which comment that was based on, but maybe the capacitor quantity. But and also Derek, I see that you clicked the raised hand button. Go ahead and type into the chat window if you have a question or a comment or something. We could use that. So does this make sense? I'm going to pause here for a second. Let me know. Do these two questions seem to make sense as a way to get better information about capacitors? Got it. Thanks, Myron. It's like a few people are typing here. It gives me a chance to get a drink of water. Yeah, it's so, and I would follow up that once we know what fails, and if they have an idea of when it will fail, how do we apply that to our situation, right? How does that work in my factory? How does that work with my customers and my product, right? So thanks for the support. Yeah, I agree. This should be happening in a development process, and the earlier the better, always. Yet it's relevant questions at any time. So if I have a failure in the field and I isolated it to a crystal, a circuit timing element called a crystal that helps run the digital circuitry, and is very common on electronics and electronics boards. And we had a problem where they were cracking. The crystal element within the component would crack, and there was some vibration in the product and so on. So we asked the vendor, how could this happen? What are we doing something wrong, or is there something wrong with the component, or whatever? And the funny, sad, funny part was is they sent us a short YouTube video of them testing their capacitor for shock loading. So these little components, they're oh, not even. I mean, they're like the fingernail size. They're smaller. They'd fit easily on the tip of your finger. So they took these little metal cans that have two leads on it, and they held it up over a piece of carpet in the office about 4 feet up, and they dropped it. And then they put it on a test circuit to show that it was still working. And that was their proof that their capacitors or their crystals were not susceptible to shock damage. Right? So they were dropping it without any circuit board or weight around it. It was just this little, very light piece, so it didn't have a whole lot of carpet and on carpet. Yeah, and so he said, no, that's not really not what we're looking at. Um, Meanwhile, we got some information back from our lab that took apart some of these crystals that were failing, and they found that the attachment, the little silver epoxy that was used to attach the crystal element to the leads, was only partially across the span of the joint, and where the epoxy ended was a high stress concentration, and that's where the crack initiated, and you could see it very clearly. So we went back and visited them and worked through improving their process so that they would get a good attachment. Because what we found was that the ones that were glued on correctly were very robust. They didn't fail. The ones that had a partial attachment failed very quickly. Obviously not with a 4-foot drop onto carpet, but when it was in a circuit board and then dropped, the amount of flex and moment that saw was high enough to crack the crystal. Another situation, I was working with a set of vendors for IGBTs. And they're a device that helps translate DC power to AC power. And it's used in like solar applications or any place where you're getting a DC power source and you want to convert it to AC. And this on their website, they had a couple of white papers, and they said if you're using our device in a high switching application, you would expect the wire bonds to fail. And here's a formula that will help you translate how often you're switching and the power magnitude of the switching to calculate your expected time to failures. And here's the distribution. And then they said, if your product, another data sheet said, if your product is used in the solar application, where it's going to be used during daylight hours and it would go quiet overnight, you get a high thermal cycling gradient across this thing. And the most likely thing to fail is the die attach. And once that cracks and delaminates basically the die attach, then we lose the ability to transfer heat. The device will overheat and fail fairly quickly. And here's a model, here's the test data that supports that model, and here's how to apply it for your application. And when we asked them the questions, well, what will fail? It was those two were dominant. And they said, here's a handful of others that may occur in isolated cases, things to be careful about. But they had put up on their data sheets and on their website the physics of failure models and the supporting evidence. They weren't hiding that their product would never fail. So somehow they got it past their marketing folks. So it was like, yeah, hotspot use with, if you lose that ability to move heat out of this component, it would just run away and fail pretty quickly. But they provided a lot of really good information so that we could understand the limitations of their product. Now, it worked out that that part would last long enough for our application, so it wasn't a showstopper. But if we were trying to make a product that was going to last 50 years, we would know it wouldn't work. But for a 10-year product, it was perfectly fine in a very small point. Yeah, get into past marketing. I wish that that company, and maybe I should just go back and ask them, is to, well, what was the net benefit of providing detailed time to failure information? I suspect that they probably sold more components because they were much more visible about what they're doing. On the other hand, I suspect that since people are not asking the right questions in general, they may not have seen any real difference. But for our application that I was working with the client on and that particular circumstance, it was critical information that helped us to cement the relationship with them and use their components. So if you're a vendor or you're supplying information to somebody, you know, Be forthcoming, provide the information. Sure, you might want to do a non-disclosure agreement or other limitations, but really, you're going to make a claim on your data sheet that it can do this. If somebody has a claim on there that it has a certain response time, there's probably a white paper or data sheet or something that supports that claim. Well, let's do the same for reliability. On the flip side, if you're working with suppliers, ask them the right questions, right? So, how do you, I know there's a lot of experience in this group that's in the webinar today. How do you ask for reliability information? And when? What prompts you to go to a supplier and ask for information? Yeah, I know that the marketing folks want to keep it vague. They don't want to admit that there's product can fail ever, all those kinds of things. I was working with it was um, a chip supplier, one of the major chip suppliers for a client of mine. They were doing a custom ASIC, and it was a huge ASIC. It was lots of money into this thing. And so I got into a meeting with the engineers that were supplying this ASIC and doing the packaging, just the packaging side of it. And I asked, so what will fail? And he says, oh, it doesn't fail. It's a standard component. We use the regular epoxy. It's a ball grid array. There's no failures whatsoever. I said, okay, really? I don't believe that. Um, uh, how do you know it doesn't fail? And they said, well, we've taken 5 units, 5 of these packages, and we ran them up to 100 degrees C for an hour, and none of them failed. He says, was it on a circuit board? Was it powered? How do you know it didn't fail? He says, well, no, they were loose, and we just in the chamber, and they weren't powered, and we took them out and we attached them to a board, and they worked just fine. Oh, okay. What else did you do? And they provided a list of about 15 standard tests. Most of them were with a single component. I think one of them was powered. Um, and one of them actually related to thermal cycling for these big ball grid arrays. And that was the one we were most interested in because we fully suspected solder joint fatigue as a major problem. And they tested 3 units. They did 100 cycles, and they did it from 20 degrees C to 60 degrees C, which is about the same range that we expected to operate this part. And so we did a little bit of quick math and worked out that they had shown with a 10% confidence that their product was at least 10% reliable over the 3-year application that we had for this product. And I asked them if that was good enough and if that was going to be justification to support their reliability claims. Now, they hadn't done those calculations for some reason. They said, well, if we run 10 different tests, yeah, best 3 units they ever did. Yeah. And to be fair, a ball grid arrays and the packaging technology they're using is pretty robust. It's just that this application we had was using lots and lots of these components. And so even a 0.5% failure rate over 3 years was going to really be very expensive for the operation of this product. And so we wanted to know if it was a 0.5% or better. And they weren't even close, not even close. So yeah, ask for it up front. I agree with you, Andrews. Is get that data up front, and it's too many components to track them all down. But as you look through your FMEA and what's new, what's risky, the new vendors, what's all of those red flags we all know about, those are the ones to just send off a standard query. What supports your reliability claims on your data sheet? Fill in the blank with what's on their data sheet. And to supplement that, please tell us what are the top three ways your product, your component will fail in this application? Quick summary of your application. And then how do you know? If it is just an engineering guess, well, I'd rather know that now than when I have a major escalation in the field later. Right? Yeah, a lot of vendors, you're exactly right, Anastasia, um, that a lot of the standards and a lot of vendor data testing is based on zero failures. And it's a very economical test, and it also doesn't have a failure, so they don't have to report we tested 27 units and 2 of them failed, because that sends off alarm bells that something failed. Yet I would rather have 25 units and 20 failed so that we can get a reasonable estimate for the time to failure distribution than 77 units ran under some obscure set of conditions and none failed. And what we're after is what will fail and when will it fail. That's what we really want to know. Yeah, and yeah, Anastasia, that's point 0.7 EV. I think Kirk's on the line. He wrote a nice article. I think it was Kirk that wrote that article about the activation energy. This point 0.7 is kind of a uniform assumption, but it's not specific to the failure mechanism. Yeah, and HALT is great. It helps us figure out what will fail, yet we still need to know when it will fail. It helps get us in that realm. Now, before I ramble on here, and I'm going to address all of your comments and so keep firing away with those things. I'm looking at over the years, I've been looking for a structure to work with vendors to ask them the right questions. So the Ministry of Defense in England created this standard some years ago that is called a reliability case, R&M case. And to summarize it, I think I've got it. It's basically, think of it as a legal argument. You're in front of the jury and you're putting together all of the evidence in a coherent, logical way that leads a reasonable person to the conclusion that the reliability claim is whatever your claim is. And what I've found in using this approach is that it works across not just engineering fields, but also with bankers and investors and all kinds of other people. That if I can go to them and say, hey, look, here's the product and design, here's our basic structure and architecture, here are the weak links to this product. We suspect and know that this material will do this component will limit this part, this thermal cycling will take apart this. Those are the most likely ways this product will fail based on our engineering judgment, our HALT testing, our internal analysis. Those are the weaknesses for our product. And here's the time to failure information that says that it will last for 20 years or 25 years or 5 years or whatever the duration is, that we'll have less than a 1% failure rate out to 10 years. And since our application's only 5 years, we can estimate that we're going to have a 0.5% failure rate at 5 years based on this analysis, which is a whole lot better than saying, well, I ran 5 units at this standard test, and I don't know how many will last for 5 years. I don't know how to translate that. Now, you might leave off I don't know part when you're making your pitch, but as a reliability engineer, I very quickly ask, well, how do you know that you were testing the right thing? What's most likely to fail, and how do you know? It's not hard questions to ask. So add that to your repertoire, add that to your procurement organization and your engineering teams that are selecting components. Ask for the case. What's the rationale behind your claim? It's really all we're asking for. Yeah, I'd rather have one article than none. In either case, though, if it's critical for us to know will it last for 5 years with a reasonably low failure rate, we're going to have to do the testing ourselves. Now, we almost always start with the vendor and ask them what did they do? How did they support their information? So we can avoid doing the testing ourselves. If it's already done, let's use it. But if it's already done, let's make sure it's good information. That's the critical part. Yeah. Um, yeah, the warranty, liability claims, the legal department, the procurement, the marketing department are are headwind to getting good information. They you know I when I've worked with vendors and I'm trying to get past the sales engineer, I says, look, here's the cost of a failure. If your component fails in my product, it costs us a warranty cost, $1,000, but it costs my customers lost sales for the day or whatever it is that impacts their part, and that's an order of magnitude higher. Now your component only costs $10, yet it's causing orders of magnitude more damage when it fails. Now, part of our due diligence in creating the design is making sure that we minimize the chance of failures and have a good understanding of what fails and what doesn't. Now, if your product cannot support how and when it will fail, we're going to have to either look for another solution or we're going to have to do the testing ourselves, and we're going to want price concessions for that. Or are you willing to pay for our customers' damage, make that right, because you're claiming your product will never fail? So you are claiming you have no risk here. Well, you do. I suspect that your product will fail, so put your money where your mouth is. But if I know how much it costs when it fails and I know what the risk is, it helps to cement the relationship of where we are in making this decision and how important it is. Now, some parts and some components are not critical to our overall system, so it's not a big deal. Yet many of our components, and I would argue that even the discrete components, or what we call uh, standard components, or commodities, that's the word I'm looking for, can cause products to fail. So let's go. Yeah. Now, Kirk, I don't buy that. The idea that the vendor can't know all of the root causes for all of the applications. The products are almost always advertised for a particular application or market. They're for the cell phone market, or they're for portable market, or they're for, whatever. Now, some components are pretty generic, and it's creative how people use your product. Yet they almost always list operating conditions and stress levels and power densities that are applied to their product and it's allowable and so on. So they know what the envelope is. I don't think it's too much to ask them to say, hey, if I'm using this product anywhere within your envelope, how long will it last? Now, if it at nominal conditions, say at room temperature with no vibration, it lasts for 50 years. But at the edges of the limits you specify, it only lasts for a week. I want to know that relationship. What's the trade off of different stresses to time to failure? I don't think that's an unreasonable question to ask. So I'm not letting a vendor off the hook just because they've got lots of customers. I'm a customer and I want this information. It's kind of one attitude around that. Now, return parts, that's after the fact. We've incurred the expense, we've had the problem, and it could be, like Takata with their airbag devices failing, and now, hundreds of millions, if not billions of dollars in recall. It's too late. As I think it was Andrew or Yi talked earlier, is that this is really a development process. As you're selecting components or you're selecting systems to put into your system, into your factory, that's when we need to ask these questions. And when we make those decisions, and doing it in retrospect is too late. Yeah, we often get caught in that scenario. But my advice is there we're in a reactive mode and it's really too late. We're going to pay the bill, the warranty, the lost customer satisfaction. All those things are going to occur now and it's too late. Sure, it's an opportunity for us to improve the system, but in my opinion, it's way too late. All right, let me see if I can get the slide to move to the next one here. So whatever it is that motivates you, instead of asking for reliability data or life data from your vendors or taking the data sheet at face value, please ask the question, what will fail and when? And push until you get a reasonable, thought out, coherent, engineering and or scientific based answer. I think that if the 50 or so of us that are on this call do that, it'll start the process of getting people to provide that information rather than just the we tested 2 of units and it passed, so it must be good, right? There's I think there's a competitive advantage, Neil, that if I have good reliability performance information, and here's how you know it's good, that's a competitive advantage, right? It, you can keep trade secret what your secret sauce is of why you get that performance you're getting. But if you know that the die attach for your IGBT is going to cause failures due to thermal cycling, well, let the vendors have enough information so that they don't warranty their product using your IGBT such that they have to replace at full cost all of their systems. You know, let's be fair in the communication both ways. The Yes, there's uncertainty in our reliability estimates and testing and so on, and there's plenty of disclaimers and all those other things. Yet when I looked at those white sheets, they were saying this is our best information, this is what we know, and here's the supporting data. And use this at your own risk. It was about as far as they went. But that's orders of magnitude way more useful in designing products or determining estimates of your system reliability than we ran this set of standard tests and they all passed. And there's no interpretation for them. So it's get back to what we're really after. Is this going to be a reliable product or not? And how do we know? Now, if you've got the facilities to do all of this testing yourself and handle the thousands of different failure mechanisms, go for it. Yet, we often are limited to like 2 or 3 things that we can really explore and understand in accelerated testing. It's that, but if we can leverage the vendor data by asking them just simply better questions, then I'd say go for that. So a similar case, if you're interested in IEC standard, is this one on the screen now. Yeah, and you're right, Neil. It really is a big part of our relationship. And let's see if I understand your comment, Yvette, that says I'm told that we can get X part anywhere else. So the vendor does not want to. Yeah, we don't always have that option. We don't always have multiple vendors that we can pick. We might have 2 or 3. If you're in that case and the one is really forthcoming with what will fail and when, I'd rather work with them as a good relationship is starting. Whereas if I get a vendor that says take it or leave it, then it's left to us to figure out if it's the right product for our system. So I don't know. I don't have all the answers here, but I have found over the years that uh, pushing the vendors to reveal what they know in a coherent way so we can make better decisions together, whether it's improve that custom component or to find another solution or to whatever, it helps everyone in the long run. Yeah, and you can't leave it. So then you're left to understanding your own risk. Then you got to do your own testing. You do your own FMEA and risk analysis, your own hull testing, figure out what will fail and go with that, or you just hope for the best. A big part of what we do as reliability engineers, though, is how do we understand what the risks are? What are we going to work with? So I'm coming up. at the end of the hour here. Let me pull up the screen that has the download so you can get that Ministry of Defense standard. Let's see where it's at here. The screen. On the right-hand side underneath the pod that says thank you, there's a pod called download the slides and paper here, so you can pull up that information if you want. But, in your world, and a number of us have mentioned some of the hurdles, marketing, legal, liability, um, um, vendors that just aren't transparent with how their product can fail and what weaknesses there are. Yes, they all exist. They're all hurdles to us trying to get good information. Doesn't relieve us of the responsibility of trying to understand how our product will work in over time, the reliability aspects of it. So hopefully I've convinced you to add a couple of questions to your repertoire. When you get a vendor on the line and they give you the 57 slide deck presentation about how wonderful their product is, if they don't answer the question of what will fail and when, you should ask that. And I'll wrap it up with that. So I'll stay on the line here for a few minutes and see if there's any other questions or comments or stuff. I think the Q&A tab's open, the chat window's open. A bunch of people have been chiming in there. I really appreciate that. And so hopefully that all made sense and hopefully will be useful for you. So yeah, I'll leave it with this ask better questions. It's really the heart of the whole presentation. So any thoughts or questions? That's right. Sometimes it takes a little persistence. But I think that if you start asking vendors for more than just MTBF or what testing you do, but how do I translate that, they'll start getting the message that they actually have to reveal how their product operates in the reliability sphere. And the more we can get vendors to do that, yes, it's going to get worked into the price of the components over time, yet it's generally a lot less expensive than doing it ourselves, and the time delay of getting those answers may be prohibitive too. So really pushing back to the vendors to get them to do due diligence on reliability. Um, you know, it, and I worked in a polymer factory. I made heating cables, and it was a component that goes into these large systems. And we did extensive modeling and testing to support those models and provided not just a simple white paper, but reports basically that listed out what the failure mechanisms were and how they affected the performance of the product over time and so on. It was great. So that's how I started in reliability engineering. And as I moved more into electronics, I found that there was a lack of information. It wasn't until I ran into this reliability case that I really realized that we should specify and ask better questions.